All right, good morning and welcome to today's class. Now we have a question I want to look together. They say that a given amount of gas occupies 10.0 dm cube at 4 atm. This atm is atmospheric pressure and 273 degrees Celsius, which is okay, we'll get there. I think we should be familiar with converting degrees Celsius to Kelvin. You just add 273 to it. Let me get my marker. Let's just take question like this. So as we have idea. Most times, if you are working with, if you want to convert your degrees Celsius to Kelvin, that will be 273 plus 273. That should be 546. If you want to convert degrees Celsius, if they give you 10 degrees Celsius, you want to convert it to Kelvin, you add 273 to it. So you have 283 Kelvin. Now, this is a question we are looking at together. You see, the number of moles of the gas present is dash. They give you the molar volume of gas at S.T.P, standard temperature and pressure, to be 22.4 dm cube. Now, there's something I want us to take note of here. Under our gas constant, this R here means gas constant. How do you get this gas constant? It's personally, you can use it from your general gas equation. Hey, my marker is wants to embarrass me. Okay, from our general gas equation, where you have your V1 P1 over T1 N1. These are the get the gas constant. V1 for 1 molar volume of gas, 20.5 times 1 atmospheric pressure over your temperature, 3 times 1 mole of a solid to give you 0.0821. So that is how we get our, that's how they got this R. We call it gas constant. If it is in ATM per mole, but there's one we used to work with too. R is also say gas constant 8.314 if it is in joules. Remember that energy is measured in joules. So if it is in joule, we make use of this when we get to the aspect of Van Hoff isothermal equation, the one that is connecting equilibrium and delta G, that is under enthalpy and energy reactions. So in a question like this now, they say a given amount of gas, occupies 10.0 dm cube at atmospheric pressure and temperature. Automatically, you know that you can introduce your what? ID gas. This PV is what's called ID gas equation. ID gas equation. ID gas equation under your gas laws. So your PV, remember that your P is your pressure, which is what? 4. Our P is the pressure, which is 4, and our V is the volume, and the volume from the question here is 10 dm cube. 10 dm cube. So PV, that is 10 times 4, which give us 40, is equals to N. This your N here means number of moles, and that's what we're looking for, times R. Your R is your gas constant, 0.0821, times your T, temperature in Kelvin. Remember, it should be in Kelvin. So that is how I told you guys. They gave us 273 degrees Celsius. So we converted it to Kelvin by adding another 273 to it, which gave us 546. 546. So coming back to this now, we are now going to have mathematical expression here. We multiply these two together, it gave us 44.8. So you divide by the quotient. Quotient is the number beside the alphabet. So 44.8 we divide by 40. So that's how give us 0.0.2. Thirdly, we give us 89 mole, which is definitely option E. Option A. So you can take a look at question like this. It's not basically that you're able to solve question like this, but you're able to solve question related to this. I get, and that's the problem students are having. They don't know when they are going to use ID gas, or when they are going to use boys, or when they are going to use charts or avogadros or grams. So basically, you should be able to start distinguishing when to use a particular formula. And this is what me I call it personally foundation chemistry, FOC, foundations of chemistry. These are basic questions. So when you see questions related to this, you should be able to just tackle it straight up. I guess now sometimes they can give you the gas constant, temperature, and and they say fine pressure or fine volume. So just basically, and please don't forget your SI unit. I've always told students it's very important. SI unit is very important. And so this question is very cheap and easy. Now let's quickly look at a particular organic compound. I used to call this one OGC, organic chemistry. It seems kind of complex. They give you this structure and they say, what is the name, the IUPAC of this compound? This is an organic compound. It's comprised basically of carbon and hydrogen. For this one, I know it is condensed. I've recommended understanding chemistry by Jokoku. Now, if I want to name a compound like this, I count how many carbon am I having? One, two, three, four, five, six. Six. That should be hexene or hexene or hexine, but I don't know. So I cannot go back. Hydrogen here is, if you look at the hydrogen here, is 14. So 6 is H14. I cannot trace it back to the family. 6 is H14 is the formula for hexene. So it means this is the condensed structure for hexane. For hexane, you can trace it back to CnH2n plus 2. CnH2n plus 2. Your N is the number of carbon atom, and you're having 6 carbon atom. That will be 6's. This is for alkane. So that's why I know that it's even under. So you have a lot of ways in identifying the compound. So this is the hexane can also be written in another form, but this is just the basic condensed form for hexane. Thank you.